Okay, so I looked at your work and I had a hard time following what was going on in this area, but everything looks pretty much for the most part like you have the right idea. For something like this, where the numbers start getting a little unfriendly, this is where I say just use your calculator. So what I did is I took this matrix here, how you have it set up, and I typed it into the calculator, and I did reduced echelon form, and I got that. So you can see you're somewhat close. You can see you're getting that 7 in there, and you're getting stuff. Generally, I just couldn't follow exactly how you all got there. But nonetheless, let's talk about this. All right, so you'll notice your first column is x, your second column is y, your third column is z. So here, when we take this out, if you kind of tear it out, so you'd have that 0, 1, negative 1, 26. So we've got x, y, z equal sign. So this first equation would be interpreted as x equals 7. The next equation would be interpreted as y minus z equals 26. So therefore, when I could solve this for y, and that would give me, what would this give me? Y equals 26 plus z. So now, how do you interpret your answer? Well, it depends what the question is asking for. If it's saying it wants things in terms of, let's say, in terms, I think this one asks for in terms of z. In terms of z, what that means is that your function of x should be in terms of z. So therefore, essentially you're doing everywhere you have an x, replace it with a z. Meaning, let's be a little more specific about that, when I go to write it in my ordered triplet, the stuff I write in here has to be z's. If there's any x's or y's, I can't have them. Numbers are fine. So let's interpret our sentence here. Now, the first one, we know x equals 7. So therefore, everywhere I have an x, I can replace that with 7. Now, for y, I'm not allowed to have y's, right? So therefore, everywhere I have a y, I have to replace that with 26 plus z. So therefore, I've got 26 plus z. Now, that works, that's okay, because it's in terms of z. So I'm allowed to have z's in my answer. So then finally, for this last thing, I don't have to replace z's, that's what I want, so z just stays z. So there would be your answer for this problem in terms of z. So it's 7 comma 26 plus z comma z. Now, what if instead the problem said I didn't want in terms of x and z, I want it in terms of x? Well, that would not be fun to do because I don't have any relationship that compares x to x and y or x and z. So what we would do to make our life a little better is we flip our columns around. So for this equation, instead of writing it in terms of x, y, then z, what we do in the calculator is write it in just a different order. It's still the same idea, it's just a different order. So when we go into this matrix, this is going to be difficult because it's off the screen. Well, I can't show you. So when I go to put it in the matrix, how I would have to fill it in, excuse me, how I'd have to fill it in here, I would want if I want it in terms of x, that means x needs to go on the right hand side. So the equal sign is always the equal sign. So then my x would go here. Then the y's and z's don't matter. I could do -1, -1, 1, 1. And then so now I've got y, z, x. And then you'll get everything in terms of x, possibly. Let me pause the video. There we go. So when you put in your calculator, this is what it spits out if you put it in this order. So then, if we were interpreting this answer, it would be saying, okay, y plus 1/2 x equals 7/2, and z plus 9/2 x equals 11/2. So therefore now, when I go to fill things in here into y, my ordered triplet, I'd say, okay, if I want it in terms of x, and then what that's saying to me is, okay, I'm allowed to have x's, so that x stays. So now I need y's. So you see we have one y there. So what we're going to do is go ahead and solve this equation for y. I'll do it right over here. So that gives me y equals 7/2 minus 1/2 x. So now everywhere I have a y, I can replace it with that. So I'm going to fill that in for my answer. It'd be 7/2 minus 1/2 x, comma. Now I need to do my z. I'm not allowed to have z's. I have to have x's. So therefore, I solve this equation for z down here, And you'll see we get z equals 11 halves minus 9 halves x. So now the beautiful thing occurs that everywhere I have a z, I can now replace it with that statement, right? And now when I fill that in, that's 11 halves minus 9, excuse me, 9 halves x. Now when you look at your answer here, you'll see it's all in terms of x. Everything has an x. X is x. Y is 7 halves minus 1 half x. Z is the same thing as 11 halves minus 9 halves x. Everything's in terms of x. And we achieve that just by rearranging our order of our columns, where when we did the original order, recall, then that put it in terms of z because z was on the right hand side, and we got a seemingly different answer, but it's really the same. It's the same setup. It's the same idea. It gives you the same system. Okay, I hope that helps.